So William Lyon, he's a software engineer at Neo4j, the open source graph database, working on integrations and extensions for graph databases as part of the Neo4j Labs team. You can find him online at Lyon, so that's LYONWJ. And William, I'm going to bring you in. I'm going to add you to the stream here. And
hey, folks.
Let's get your, let's see if we can do this right. There we go. So there's me, there's you. And yeah, and so you are going to be doing a talk on GraphQL APIs backed by Neo4j. So the talk you're doing, building GraphQL APIs backed by Neo4j is easier than ever before with low-code tools like GraphQL Architect Graph app for Neo4j Desktop. In this talk, we're going to look at how to create GraphQL APIs backed by Neo4j, as well as leveraging some of the geospatial functionality of Neo4j via GraphQL in the context of building a real estate search application. So with that, William, I think I will hand the reins over to you if you are good to go.
Great. Sounds awesome. Good.
I will pop out and yeah, have at it.
Okay, great. Well, hey, everyone. So the title of my talk, like Ryan said, is Low-Code GraphQL with Neo4j. If you want to grab the slides, they're available at that bit.ly link, bit.ly/GraphQL-Berlin-Neo4j. So what I want to cover in this talk are a few things. One, I want to talk just a little bit about Neo4j and graph databases to give you some context, but then also talk a bit about why we would use GraphQL with Neo4j. I'd like to talk a bit about some of the tooling that's available that makes it easier to build GraphQL APIs backed by Neo4j, and then also talk a little bit about how we build some of those tools. So that's the plan. A little bit about me, like Ryan said, I work for a database company called Neo4j. That's a graph database, which we'll talk about in a minute. And I don't work on the core database itself. Instead, I work on toolings, integrations, and extensions to the database as part of what we call the Neo4j Labs team. I've also been working on writing a book called Full Stack GraphQL Applications with GrandStack. Published by Manning. It's out in early release now. That link, bit.ly fullstack-GraphQL-ebook, is actually a link to a free excerpt of the first 3 chapters from the book. So a lot of what I've learned working with GraphQL and Neo4j, and a lot about what I'm talking about today is covered in this book as well. So if that sounds interesting, I would check out that free download for the first excerpt of it. Cool. So what is Neo4j? If you're not familiar with Neo4j, Neo4j is a graph database. So what that means is it's a database management system like other databases, but instead of tables or documents, the data model is a graph. So nodes are the entities, relationships connect them. We use a query language called Cypher, which you can think of as a declarative pattern matching language. So here's an example where we're sort of drawing these ASCII art representations of the graph pattern that we're looking for, and then some operations for how we want to work on that pattern. That's largely what Cypher is. But there's also lots of interesting things we can do with graph databases. They have very different performance characteristics from, say, relational databases or other types of databases. So the use cases can be interesting, anything from things like personalized recommendations, graph analytics. The graph data model is also, I think, a bit more intuitive than when you're working with relational ER diagrams and thinking about modeling that way. And then also there's lots of interesting tooling. So we'll talk today about the GraphQL integration. So really when we talk about Neo4j, the core of this is a database, but there's lots of interesting parts of the Neo4j platform, from visualization, analytics, integrations with other frameworks as well. So I want to show just a little bit of Cypher on a data set of business reviews, just to give you a bit of an idea of how we use Neo4j. So I'm going to jump over to, this is Neo4j Desktop, which is kind of like a a mission control, I guess, for Neo4j. And this tool, this is Neo4j browser. So this allows me to write Cypher queries, dot visualization. There we go. So this allows me to write Cypher queries, and let's do a style reset. There we go. To write Cypher queries and kind of work with the results. So here I did a call db.schema.visualization just to show, okay, what's the data model that we're working with here. So I have a data set of users that have written reviews, that review businesses, and businesses are in a category. So this is the graph model of the data we have loaded in here. And it's just kind of sample data that I basically made up. So I want to look at first a shorter Cypher query. So here we're drawing this sort of ASCII art representation of a graph pattern. So you can think of these parentheses as indicating a node. Here we have a label. So labels are the way that we group these nodes. So here we're saying find a node with a label category, and then we can store arbitrary key value pair properties on nodes or relationships. So here we're saying match where the name is breakfast. So find the node that represents the category breakfast. And then here we're drawing sort of an arrow, and we're saying, okay, now find incoming relationships of the type in category and find businesses connected to that category relationship. So here we're saying, find every business that's connected to the category breakfast and then return that piece of the graph. And you can see we have two businesses that are in the category breakfast. So mark it on front. We can see we're storing some arbitrary key value properties. We have an address, business has an ID, a location, and so on. And I can traverse out from here just by double clicking, and I can see users that have written reviews of this business, what other businesses have they written reviews in, and so on. We can create more complex graph patterns. So here's a bit more complicated query where we're saying, let's zoom out a little bit so we can get that full pattern. So here we're saying, okay, if you like this business called Kettle House, which it's Kettle House is a brewery, then what other businesses might you be interested in? So this is a collaborative filtering recommendation query because we're looking for users that have written reviews of this business that I'm interested in. And then we're saying what other businesses have those users written reviews of, where that business is not Kettle House, and those businesses are in completely different category from Kettle House. And then I want to return the name of that business as a recommendation and find the categories of that business that I'm recommending with this graph pattern. And then I'm going to count the number of those paths. So essentially the number of users that have also written a review for this business I'm recommending. And that's sort of a score for our recommendation query. So this is sort of a users who like this thing also like this other thing type of query that can be expressed in a graph database using Cypher. Cool, so that's just a little bit about Neo4j and Cypher to give you an idea of how we use Cypher with Neo4j. Now I want to talk about how we can use GraphQL with Neo4j. So using a database as the data layer for an API is a very common thing that we want to do. We want to make this data available to a client application, to other services within the enterprise, that kind of thing. And a GraphQL API is a natural way to do that. There's, I think, really this symbiotic relationship, though, when we're talking about using a graph database as the backend for a GraphQL API. And first of all, GraphQL makes this observation that our application data is a graph. So it gets us thinking and modeling our data as a graph. And when we're using a graph database, we've already gone through that process of thinking in terms of graphs, modeling and storing, querying our data as a graph. So there's a nice sort of one-to-one mapping there of graph to graph, graph on the front end, graph on the back end. So when GraphQL was first open sourced, this was something, of course, that we were very interested in the first time that we saw this. And we were thinking, wow, is this something that makes sense to use with Neo4j? What sort of tooling can we build to make it easier for developers to build APIs, GraphQL APIs backed by Neo4j? And so we went through this exercise of talking to some early GraphQL users that were using GraphQL with Neo4j, asking them, what are they building? What are the pain points? And we sort of came up with some goals for what a Neo4j GraphQL integration would look like. At a high level, we realized there's lots of boilerplate data fetching code that that users are writing, and any sort of integration that we build, we want to make sure we're getting rid of a lot of that boilerplate, something that is helping developers be productive, get up and running with their API, but also we need something that's going to be extensible and performant. So narrowing down the goals then, it became pretty clear what we thought would be interesting features for a Neo4j GraphQL integration. And so the first one is this idea of GraphQL first development, where your schema, your type definitions in GraphQL are driving the data model in the database. So we take GraphQL type definitions, and rather that's defined with SDL or programmatically building type definitions as part of a schema. We use that to drive the data model in the database, basically mapping GraphQL types to node labels in the database. So we saw before where we're querying nodes that have the label category, basically that maps to a type in GraphQL. And the benefit of this really is we're reducing the need to maintain two schemas. So rather than maintaining a schema for your database and a schema for your API, you're using the same graph schema in both of these. The other feature that we wanted to add here is going from just those type definitions to auto-generating a full CRUD GraphQL API. So this means adding query and mutation fields, adding arguments for ordering, pagination, filtering, adding some of the spatial and datetime types as well. And then for any arbitrary GraphQL request, we want to translate that to a single Cypher statement and send that in one round trip to the database. So this has two advantages. One, it means we don't have to write any resolvers when we're using Neo4j GraphQL. And it also means that we're only dealing with one database query for any arbitrary GraphQL request. So GraphQL, very nested. A lot of times with other implementations, we can end up sending lots of requests to our data layer, if that's a database, back and forth for a very nested query. But with Neo4j GraphQL, we build up one Cypher query and send that in one round trip to the database. And then the other point we wanted to think about here is extensibility. So how do we add custom logic on top of this CRUD GraphQL API? And what we came up with here is the Cypher GraphQL schema directive. So a schema directive in GraphQL is sort of like an annotation on a type or a field that says, hey, there's some custom logic that should happen on the server here. And with the Cypher directive, this allows you to define computed fields in your GraphQL schema, where you're binding the value of that field to a Cypher statement. So here in this screenshot, we're adding a recommended field on the business type. And what this is doing is this is very similar to the business recommendation Cypher query we saw a minute ago, but now we're embedding this in GraphQL. So now we've added a recommended field to our GraphQL API that's going to run this Cypher statement and find recommended businesses for the business we're resolving. Cool, so currently there are 3 implementations of Neo4j GraphQL. There's a JavaScript library that is designed to work with any of the JavaScript GraphQL server implementations, like Apollo Server, Yoga, things like that. There's a similar library for the Java ecosystem, and then there's a plugin for the database itself. And this integration is part of a larger project called GrandStack, which aims to show how to use GraphQL and enable developers by building tooling to build full stack applications using GraphQL, React, Apollo, and Neo4j database. So you can find the documentation examples on grandstack.io for these. So I want to dive in a little bit deeper on one of these libraries. So Neo4j GraphQL JS. So how does this work and what is it doing? Well, the goal of the Neo4j GraphQL integrations are, not to make the database itself speak GraphQL. GraphQL is very much not designed to be a database query language, and you still really often want that API layer that sits between the database and the client that allows you to implement things like authorization, caching, connecting to different data sources, things like that. So that's the goal, is to still build this API layer, but just make it easier to work with Neo4j. So there's sort of 2 main functions of this library. There's the schema augmentation, where we're taking GraphQL type definitions and adding query and mutation types, adding all of those filtering, ordering, pagination, all the input types associated with that. And then there's the GraphQL transpilation process, where we're taking a GraphQL operation and translating that to a database query. So let's take a quick look at an example using Neo4j GraphQL JS. So this is a code sandbox. The link's here. There's also the code for this on GitHub. Looks like we need to refresh that. So this code sandbox, this is pointed to a cloud Neo4j database. This is a read-only user, so don't worry about the credentials there. And what we're doing is using Apollo Server and Neo4j GraphQL JS to spin up a GraphQL API. And this is the same data set that we saw in Neo4j a minute ago with those business reviews. And we can see we have query fields for each node label and mutations for all of the creating, updating, and deleting nodes and relationships. So here, if we run a query, here we're saying find all of the businesses, their name, and then find all of the reviews that they're connected to. So we get back a bunch of data. What's interesting though, if we look here in the console, we can see that we're logging, in this case, this is the generated Cypher query. So this is our GraphQL request. Here's the Cypher query that was generated from that using the Neo4j GraphQL JS library. And if we look at the code for this, let me try to make a little bit of space here and zoom in a little bit. So what we're doing is importing make augmented schema from Neo4j GraphQL JS, importing Apollo Server and the Neo4j JavaScript driver. So that allows us to send Cypher queries to a database. Then we're also importing some things to read environment variables and import a schema file. Really, what we're doing here is grabbing some type definitions from schema.graphql file, which we'll take a look at in a minute, but just imagine some standard, almost standard GraphQL type definitions that we're passing to make augmented schema, which gives us back a GraphQL schema object. and we pass that to Apollo server. We also need to create a Neo4j driver instance to connect to Neo4j, and then include that in this context object so that our GraphQL resolvers have a connection to the database. But if you notice here, we didn't write any resolvers. We didn't have to write any logic that says, this is how you fetch data from the database for this field on this type, and so on. All of this is driven using this make augmented schema function from Neo4j GraphQL JS, driven from our GraphQL type definitions. And you can see here that this maps to our data model that we have in Neo4j. We have one type per node label. Fields are mapped to node properties in the database. You can see we do add an @relation directive. So we saw previously when we were querying Neo4j that we had a relationship type and a direction for every relationship. We don't really have that same concept in GraphQL. So this @relation directive is sort of a way just to store that metadata. And here's an example of a Cypher schema directive. So on business, we have this recommended field where we've added a Cypher directive that has a Cypher query that says, hey, if you like this business, what other businesses are users that reviewed this business also reviewing? So if we add that field to our query, so let's say, give me now for every business the recommended business. So if I say like the Missoula Public Library, here's another business that I might be interested in. And if we look at the generated query this time, we can see now that recommended field includes as a subquery the Cypher query that we attached here in our GraphQL schema. Cool, so that is a brief overview of Neo4j GraphQL JS. As a little bit of an aside, how do we generate those database queries? Well, every resolver in GraphQL is passed a few things. The make augmented schema process that's generating resolvers, or generated resolvers, are passed this object called resolve info. And in that resolve info object, there's a lot of things, but the things that we can use to generate a database query include a representation of the GraphQL schema, the name of the field that we're currently resolving, and a representation of the selection set. So essentially, what we can do is find the nested selection set of the GraphQL query, so at the root level, so in the root level resolver, so typically the query or mutation field resolver. We can sort of look ahead to see, okay, what's the entire selection set, and then iterate through that and generate a single database query from that root resolver. And then we also use this GraphQL resolve info to implement those schema directives that we saw @relation and @Cypher. So once we have a nested selection set representation of that, we can iterate through that, building up our Cypher query. So it might look something like this. And we saw in Neo4j browser, we have the ability to return graph objects, or we can return sort of a projection from that to return tabular data. And what we do is we build up a projection. So basically, we do the traversal that you specify in the nested selection set, and then project out only the fields that are being returned in the GraphQL query. So then that returns sort of a JSON object, essentially, that maps to the data requested in GraphQL. Now for schema directives, like @relation and @Cypher, these then map, or I should say, the Cypher schema directive maps to subqueries that are then added in that Cypher query. So we're still generating a single round trip to the database, even when we have that custom logic defined in the Cypher schema directives, which is pretty neat. There's other ways of implementing schema directives. There's a nice package in GraphQL tools that gives us some classes to work with for implementing schema directives. And for example, we've built a GraphQL auth directives package that uses GraphQL tools to add authorization logic using schema directives this way. If you're interested in that approach, how these database GraphQL integrations work, I gave a talk at GraphQL Summit last year that goes into a lot more depth. So check that out if you're interested. Okay, cool. So so I thought this talk was going to be about low-code GraphQL, though. What does that really mean? Like I said, I would argue that we've been talking about low-code GraphQL the whole time. Low code is this buzzword that gets thrown around a lot, and I think really developers aren't really interested in the buzzwords. What they're interested in is tools that solve problems that they have. So I think really there's this low code spectrum, and maybe it goes something like this: from libraries and integrations, where I'm importing that package, I'm writing some code to use it, but it's in this case generating resolvers and augmenting the schema and generating database fetching code for me, right? So low code, I would say, is any tool that enables us to achieve a goal by writing less code. If we sort of move a little bit further down that spectrum, we have command line tools, things like Create GrandStack app and the GrandStack CLI. Create GrandStack app allows us to basically template out a full GrandStack application from the command line and then start from there, kind of like Create React app is for the React ecosystem. And then the GrandStack CLI has a bunch of functionality, but basically one thing we can do is give it type definitions or a Neo4j endpoint, and it will spin up a GraphQL API for us. And then further down the spectrum, we have these UI-driven tools, things like GraphQL Architect, which is something I want to show just really quickly. GraphQL Architect is sort of like a plugin for Neo4j Desktop. We call these things graph apps for Neo4j Desktop. So these are developer tools that have a UI that integrate with Neo4j Desktop that allow us to do various things. And in this case, GraphQL Architect is built on top of Neo4j GraphQL JS and the GrandStack CLI, and allows us to do a lot of things with building GraphQL APIs. So I'm going to switch back to Neo4j Desktop, and now I'm going to open GraphQL Architect, and that'll open up here. And so the first thing that happens when I open GraphQL Architect, let me make this a bit bigger so easier to see. First thing that happens is it inspects my currently running Neo4j database and generates some GraphQL type definitions from the database. So inspecting the data model, it says, hey, here are the equivalent GraphQL type definitions for what data you have in the database. And then I can start a local GraphQL API. Oh, I have something running on that port already. Let's try 4004. There we go. So now, based on these type definitions, it's spun up a GraphQL API. We can switch over to graphical. So I should be able to do something like show me businesses and, I don't know, their name and location. And then the idea is, well, I can edit my type definitions. So we have a GraphQL type definition editor. This by the way, is using the GraphQL Monaco library from Graphical, which is a great library if you want things like schema-aware syntax highlighting and autocomplete. So maybe I want to add a maybe average stars field. So I can do that, look something like this. I'm going to match where we have reviews that are reviewing this business and return the average of the stars field. And now if I restart, I should have an average stars field that I can add. I can order by that field. If we say order by average stars descending. And then I have lots of nice filtering functionality here as well. So let's say I want to filter where the location distance is less than a certain value, let's say maybe 2 kilometers from where I currently am. I have that latitude and longitude saved right here. Right, so here I can do more complex filtering. So now I'm saying find businesses that are within 2 kilometers of this point, order by average stars. Cool, so that's GraphQL Architect. Oh, the other thing really quickly that I can do, so once I've done that is then I've developed my API and now I can export it. We have a GitHub integration. I can export JavaScript code locally or push it to GitHub. Cool, so that's kind of a whirlwind look at some Neo4j GraphQL tooling, some of the things we've been working on. Just really quickly, I'll leave with a few resources if you're interested in digging in more to this. I have been doing a Twitch stream every Thursday. We've been building a Zillow clone with GraphQL and Neo4j. So I was going to talk a little bit more about some of that functionality, but that's probably enough of a whirlwind so far. So please join me on the live stream on the Twitch channel. Next up, I think we'll do a book club of our full stack GraphQL book. So if you're interested in this, download the free ebook and then join us on Twitch. And I think we'll work through maybe one chapter every week in the book club. So that should be fun. Hopefully folks can join that. If you're looking for the docs and examples for everything I talked about are on grandstack.io.
Awesome.
That is all I have.
William, that was a great talk, man. There was one question I think that I came across in the chat here. I'm going to pop it onto the screen. The question is, wondering how do you optimize for production? As I saw, generated query was already quite large. How does this scale?
Yeah, that's a great question. So a few points, right, is the sort of full CRUD generated API basically throws all of the options at us for all of the filtering options on all of the types that we want. And, you know, there are things we need to think about at the database level for making sure that we're, you know, performant results are what we're getting. And so there's a few things we can look at. One is creating database constraints and indexes based on our schema. So we have the ability to basically add some directives in the GraphQL schema that can then, here we go, that can then define constraints and indexes that we want to create in the database. So, you know, any fields that we know we're going to be filtering on or using in, say, a query field, we want to make sure that we have an index in the database. If we have many of those nodes, and similar for constraints. And then we can also configure the generated API. So we can remove types if we don't want those to be exposed as query types. We can remove certain things from what we give the options to filter on if we dump out the generated SDL and work with that. So yeah, the goal I think is to get up and running very quickly and then to have some configuration options. And then if we want to go further for optimizing for performance, we can also implement any resolvers and those will override any of the generated resolvers. So if we have some performance optimized query or code that we want to use to replace anything that's generated, we can attach that as well.
Great. Oh, that's awesome. Well, I really enjoyed your talk, William, and I'm realizing I think you and I were back to back at GraphQL Summit last year, if I'm not
Exactly.
mistaken, right?
Yeah.
We're
Yeah.
on the same
Exactly.
stage back to back. It's good to see
Yep.
you again and be on stage virtually with you this time. But
You
great to
too,
see
yeah.
you. Thank you very much for this talk. If people want to get in touch with you and learn more about Neo4j, I'm assuming the best spot would be your Twitter, which is LYONWJ. Is that correct?
Yeah. Yeah. Exactly.
All right. Very cool. Well, thank you. And hopefully you can stick around and maybe pop into the chat if people have questions.
Of course.
And
Absolutely.
we will otherwise chat with you soon.
All right. Thanks, folks.
All right.